Dark matter, the hidden architect of the universe's structure, just revealed. Scientists have finally discovered what we think is the true nature of dark matter, but what they found out is so strange that it could revolutionize everything we know about our existence. It turns out that dark matter isn't just a mysterious substance that makes up most of the mass in the universe. It's also the hidden architect shaping the very structure of space-time itself. It's like if someone was looking at the night sky and seeing not just stars, but also the blueprint for how they're all connected. What scientists are now saying is that this dark matter is more than just a building block. It's the master planner orchestrating the grand design of the cosmos. So buckle up, because we're about to dive into some seriously mind-blowing stuff. If confirmed, this would mean that dark matter particles are actually tiny black holes, which has some pretty mind-bending implications. Not only does it mean that these dark matter particles are like miniature black holes, but it also means that they were created in the moments after the Big Bang, when the universe was still super hot and dense. As the universe expanded and cooled, these dark matter particles formed a kind of scaffolding that everything else in the universe could hang out on. And get this, it's this dark matter scaffolding that's responsible for the large-scale structure of the universe. The way galaxies are grouped together in clusters and superclusters separated by these vast cosmic deserts. But wait, there's more. These tiny black holes also have a gravitational pull, and it's this gravity that affects how galaxies move through space. They're like these invisible hands guiding the dance of the galaxies. But here's where things get really interesting. The strength of this gravitational pull depends on the mass of the black hole, and guess what? The more massive a black hole is, the stronger its gravitational pull. That means that the larger these dark matter black holes grew, the more influence they had over the galaxies around them, kind of like a cosmic tug-of-war. And here's where things take a turn for the weird. Scientists believe that these dark matter black holes didn't just grow by gobbling up stuff in the early universe. They actually merged with each other, creating even bigger black holes. And this merging process would have affected how galaxies moved in a really specific way. Smaller black holes would have caused galaxies to speed up, while larger ones would have made them slow down. This could explain why we see some parts of the universe speeding away from us faster than others. It's like these dark matter black holes are playing a cosmic game of chicken with the galaxies. And get this. These collisions between dark matter black holes might have even created ripples in space, and we might have detected some of those ripples as gravitational waves. Talk about a cosmic collision course. Now, before we continue, please take a moment to subscribe to the channel. Your support helps us continue our work and reach more people with these important updates. So why do scientists think that dark matter is made up of these tiny black holes? Well, it comes down to some pretty mind-blowing math. See, solving Einstein's equations for general relativity requires making some pretty gnarly assumptions about the behavior of matter. One of those assumptions is the equivalence principle, which basically says that the effects of gravity are the same no matter where you are in the universe. But here's where things get weird. When scientists try to apply this principle to dark matter, they run into a problem. It doesn't work. For example, if you take a bunch of dark matter and try to make it rotate, it should form a perfect sphere, right? But when they tried to do this in their simulations, they found that the dark matter formed these weird, lumpy structures instead. It was like trying to spin a ball of dough and having it turn into a pretzel. Not exactly what they were expecting, but then something amazing happened. When they introduced these tiny black holes into the mix, everything suddenly made sense. The dark matter particles formed a smooth, even sphere, just like they had predicted. It was like finding the missing piece of a really complicated puzzle. What's more, these black hole dark matter particles have the same mass and gravitational pull as the regular matter we're made of, which could explain why we don't notice them. They're like these sneaky ninjas blending in with the crowd. But here's the kicker. The math that describes these tiny black holes also predicts that they should evaporate over time, leaving behind a whole lot of nothing. And that doesn't sit well with scientists, because we have evidence that dark matter is here to stay. It's like if you put a cup of water on a table and then came back to find that it had vanished without a trace. Where did it go? How can something just disappear without leaving a single ripple? That's where the idea of primordial black holes comes in. Primordial black holes are black holes that formed in the very first moments of the universe. Back when it was a hot, dense soup of elementary particles, these black holes were born from the quantum fluctuations of the universe. Tiny variations in space-time that popped in and out of existence like cosmic popcorn. It was like these little black holes were the universe's way of saying, I'm here, I'm gonna be big, and no one's gonna stop me. As the universe expanded, these black holes grew along with it, gobbling up everything in their path, including light. That's why we can't see them directly. They're like cosmic Pac-Man, but with way more teeth. But here's where things get really interesting. These primordial black holes are a lot more than just cosmic Pac. They're also a potential solution to the mystery of dark matter. That's because the mass of these black holes could account for a significant portion of the mass in the universe, the so-called dark matter. And that means that not only could they be the key to understanding the structure of the universe, but they could also help us solve one of the biggest mysteries of modern science. And get this, it's not just theoretical either. Scientists have actually spotted some of these primordial black holes, and they're pretty massive. We're talking billions of times the mass of our sun. But here's the thing. those big guys don't really fit the bill when it comes to explaining dark matter. You see, according to our current understanding of physics, these big black holes should have formed a long time ago, and they would have disrupted the cosmic microwave background, this faint glow that's left over from the Big Bang. But scientists have studied the cosmic microwave background, and they haven't seen any signs of these big black holes. It's like trying to find a needle in a haystack, except the needle is a giant black hole, and the haystack is the entire universe. So if the big black holes don't work, maybe we should take a closer look at the smaller ones. And that's exactly what scientists did. They started looking for these small black holes, and guess what they found? A few of them. And here's where things get really exciting. These small black holes could have formed in the first moments of the universe, and they wouldn't have left any noticeable imprint on the cosmic microwave background. In other words, they could be hiding in plain sight. It's like they're playing cosmic hide and seek, and we're finally getting good at the game. Now, I know what you're thinking. Why do we care about all this black hole stuff anyway? Well, because it could change everything. If we confirm that dark matter is made up of these small black holes, it would mean that we need to rethink our understanding of the universe. We'd have to go back to the drawing board and come up with new theories about how the universe works. And that's not just some abstract nerd stuff. It could have real-world implications too. For example, finding these black holes could help us develop new technologies for detecting and measuring things in space. It could also give us insights into the nature of time and gravity. Maybe we'll even find a way to travel through black holes. Well, maybe not that last one. Either way, the bottom line is that finding these black holes would be a major breakthrough for science, and it could change the world as we know it. So keep an eye out for those black holes. You never know when they might pop up and surprise us. And that's just the tip of the iceberg. There's so much more to discover about the universe and our place in it. If you want to learn more about the incredible mysteries of space and the groundbreaking discoveries that are being made, be sure to check out our other videos. With each new video, we bring you closer to understanding the wonders of the cosmos. So hit that subscribe button and join us on this incredible journey of discovery. Who knows what wonders we might find next?